Welcome, everyone, to this session on Aventis Graduate School's policy on ethical AI use, particularly in the context of course assessments. Today, we will be diving into some critical aspects of this policy to ensure we all have a clear understanding of the expectations, opportunities, and responsibilities that come with the integration of AI into our academic environment. Harnessing generative AI, empowering faculty and students. In this section, we will explore how generative AI can empower both faculty and students in an educational setting. We will delve into the basic concepts of AI, its historical context, and its modern applications. Part 1. Introduction to Generative AI. What is artificial intelligence? AI systems are designed to solve complex problems that were traditionally solved by human intelligence. The technology continuously evolves, allowing machines to enhance their own capabilities over time. Artificial intelligence, AI, originated in the mid-20th century in the United States, aiming to create machines capable of human-like communication. A quick guide on AI can be found on this YouTube video. You pause this video to watch it at your own pace. Remember to come back after watching it. History of artificial intelligence. Let's take a journey through the fascinating history of artificial intelligence, as depicted in this timeline. 1940s. The dawn of AI. We start in the 1940s, where the foundational concepts of AI began to take shape. This period marked the development of neural networks, which are computer systems modeled after the human brain's network of neurons. These early neural networks laid the groundwork for the sophisticated AI we have today. 1950s. The Turing test and early chatbots. Moving into the 1950s, we encounter the Turing test, proposed by Alan Turing. This test was designed to evaluate a machine's ability to exhibit intelligent behavior indistinguishable from a human. Additionally, this decade saw the creation of the world's first chatbot, which was a significant milestone in enabling machines to interact with humans using natural language. 1960s. Expert systems. In the 1960s, AI research advanced with the development of expert systems. These systems were designed to mimic the decision-making abilities of human experts in specific fields, such as medical diagnosis or engineering. 1980s. Computer vision. The 1980s brought about significant progress in computer vision, the technology that enables machines to interpret and make decisions based on visual data from the world. This advancement allowed computers to recognize and process images, paving the way for innovations like facial recognition and autonomous vehicles. 2000s. AI in everyday applications. Fast forward to the 2000s, and we see AI becoming more integrated into everyday life. Companies like Google, Yelp, and Waze utilized AI for recommendation systems and navigation, analyzing user behavior and preferences to provide personalized experiences and real-time traffic updates. 2010s. AI achievements in games. The 2010s were marked by AI's remarkable achievements in complex games. AI systems defeated human champions in games like Jeopardy, chess, and Go, showcasing their advanced problem-solving and strategic thinking abilities. 2020s. The rise of LLMs. Finally, in the 2020s, we witnessed the rise of large language models, LLMs, such as ChatGPT. These models have reached the milestone of passing the Turing test, demonstrating their ability to generate human-like text and engage in coherent and contextually appropriate conversations. This era signifies AI's capabilities reaching new heights, with applications spanning customer support, content creation, and more. This timeline highlights the key milestones in the evolution of AI, showing how far we've come from the initial concepts to the advanced intelligent systems we have today. Each decade has brought us closer to creating machines that can think, learn, and interact with the world in increasingly sophisticated ways. Applications of artificial intelligence. Artificial intelligence, AI, is prevalent in various sectors today, with applications ranging from virtual assistants like Siri and Alexa that use natural language processing to understand and respond to user queries, to recommendation systems employed by platforms like Netflix and Amazon that analyze user behavior to suggest content or products. Examples of artificial intelligence: a conversational AI that uses deep learning to generate human-like text based on input prompts. It's widely used for customer support, content creation, and more. ChatGPT, a conversational AI that uses deep learning to generate human-like text based on input prompts. It's widely used for customer support, content creation, and more. Google Translate, translation service that uses neural networks to convert text from one language to another. It supports over 100 languages and is constantly improving its accuracy. Netflix Recommendations utilizes machine learning to analyze users' viewing history and suggest movies and TV shows that match their preferences, enhancing user experience. Tesla's Autopilot employs computer vision and sensor data to enable semi-autonomous driving. It can handle tasks like lane keeping, adaptive cruise control, and even automated parking. What is generative AI? Generative AI refers to a subset of artificial intelligence technologies that specialize in generating new content by learning from vast amounts of existing data. This type of AI employs machine learning models, particularly those trained using deep learning techniques, to produce outputs that are similar in form and quality to human-generated content. The content created by generative AI encompasses a wide range of formats, including text, images, audio, video, and even computer code. Generative AI can produce original outputs that mimic human creativity. Key technologies. What is generative AI? Generative AI is widely applied across various fields, including education, healthcare, and the creative arts, offering innovative solutions and enhancing productivity, although it also raises ethical considerations and challenges regarding the quality and misuse of generated content. Natural language processing, NLP, used in models like GPT-4, Gemini, and Claude for text generation. Other examples include automation and efficiency. By automating content creation, generative AI significantly reduces the time and effort required for complex outputs, enhancing efficiency. Learning from data. Generative AI systems improve as they process more data, learning patterns and styles to produce high-quality outputs. Creation of novel content. Unlike other AI systems that primarily analyze data, generative AI creates new content, offering innovative solutions and designs. Part 2. Applications of generative AI in education. This section will explore the various applications of generative AI in education. We will look at how AI can create personalized learning content, automate grading and feedback, and support educators through virtual teaching assistants. Applications of generative AI in education: personalized learning content. Generative AI can create customized learning materials tailored to individual student needs, enhancing the learning experience by addressing different learning styles and paces. Automated grading and feedback. AI-powered tools can automatically grade assignments and provide instant, detailed feedback, saving educators time and offering students immediate insights into their performance. Virtual teaching assistants. Generative AI can support teachers by acting as virtual assistants, helping to answer student queries, facilitate discussions, and provide additional resources, thereby improving overall engagement. Let's explore how instructional designers can adapt to AI technology, as depicted in this diagram. Evaluate competency of resources. Assess the current skills of your team to identify what new skills are needed to integrate AI effectively. Actively learn AI. Stay informed and continuously educate yourself about AI technologies and their applications in education. Think about the impact of AI design on their market segment. Understand how AI can influence your specific field and tailor solutions to meet the unique needs of your audience. Use and understand all kinds of design. Incorporate principles from graphic, user experience, and interaction design to create comprehensive AI-enhanced learning experiences. Understand what is possible via AI technology. Know the capabilities and limitations of AI to set realistic expectations and innovate effectively. Think critically about AI technology. Consider the ethical and social implications of AI use, ensuring it is applied responsibly and inclusively. Generative AI's role in modern instructional design. Marking essays. AI tools can automatically grade assignments, providing immediate feedback and saving instructors time. Developing rubrics. AI can help create detailed grading rubrics, ensuring consistency and clarity in assessment criteria. Generating discussion prompts. AI can produce engaging and thought-provoking questions to stimulate classroom discussions. Assisting with lesson planning. AI can suggest lesson structures, resources, and activities tailored to diverse learning styles. Planning notes for tutorials. AI can generate comprehensive notes and outlines for tutorial sessions, enhancing instructional efficiency. Next, watch this short video on integrating generative AI with education, reinventing the teaching experience. Reflection. In this section, we will reflect on the skills students need to develop to effectively use generative AI as a learning tool, and how educators can facilitate this. We will also evaluate the ethical considerations and challenges associated with integrating generative AI into teaching practices. What skills do you think students will need to develop to effectively use generative AI as a learning tool, and how can you facilitate this? Evaluate the ethical considerations and challenges associated with integrating generative AI into your teaching practice. How would you integrate a generative AI tool into your teaching practice? What benefits and challenges do you foresee? Here are the references we used. Take your time to view them if you wish to. Part 3. Ethical and privacy concerns about the use of generative AI in education. This section will delve into the ethical and privacy concerns associated with the use of generative AI in education. We will explore issues such as job displacement, bias in automated systems, and the environmental impact of AI. Concern about use of generative AI in education. Initial concerns of AI in education often revolve around concerns regarding job displacement and the potential for bias in automated systems. However, these views have evolved to recognize AI's potential to enhance learning experiences through personalized education, efficient administrative tasks, and augmented teaching capabilities. Ethical considerations and challenges of using generative AI in teaching and learning. Sourced from Ethical AI for Teaching and Learning by Cornell University. There are many open questions, including legal questions regarding the ethical design, development, use, and evaluation of generative AI in teaching and learning. While generative AI may potentially be powerfully useful, concerns and sensitivities surround a number of key issues, including transparency and oversight. As many generative AI are developed and owned by corporations, how can we know how the tools are trained or what safeguards exist protecting users against inaccurate information or harmful interactions? Environmental impact. As generative AI tools are trained with ever larger data sets requiring more and more energy consumption, what is the energy use impact on the environment? Diversity, non-discrimination, and fairness. How can we ensure that tools avoid unfair bias and are universally accessible? Privacy, data governance, technical robustness, and safety. How is user data or copyrighted material used, stored, or shared? Who has access to user data? European Commission, 2022. Questions for instructors to consider when evaluating generative AI content. Here are a few questions for instructors to consider when evaluating generative AI content. Is the AI-generated content accurate? How can you test or assess the accuracy? Can other credible sources, outside of generative AI, validate the data or item produced? How does the information generated impact or influence your thinking on this topic? Who is represented in this data? Is the data inclusive in terms of the material's scope and the perspectives that it presents? Knowing LLMs may also be collecting the data your students input. i.e., in their prompts. How will you make students aware of this practice and safeguard their privacy? Explore the capabilities, limitations, and ethics of AI here in this video. Take your time to watch it through. Further readings. For more in-depth understanding and further reading, the following resources are recommended. Part 4: Collaborative Learning and AI. This section will explore the role of AI in collaborative learning environments. We will discuss how AI can enhance student cooperation, teacher-student communication, and overall learning outcomes. Role of educators and collaborative learning. This approach is grounded in the notion that learning is fundamentally social, with the most effective learning happening when students are actively engaged in tasks, developing new understandings through peer interactions and discussions. However, the success of collaborative learning often relies on effective communication and the smooth exchange of ideas. Generative AI tools like Copilot or ChatGPT can significantly improve this process. Educators guide students in collaborative activities, fostering an environment that encourages teamwork and critical thinking. Integrating collaborative tasks into the curriculum enhances learning outcomes by promoting peer interaction and shared problem-solving. Continuous student feedback allows educators to adapt teaching methods and collaborative strategies to meet diverse learning needs. AI in collaborative educational environments. Adaptive and personalized learning. AI can analyze student performance and learning styles, then tailor content and activities to meet individual needs within a group setting. ASDSDSI virtual assistants. AI virtual assistants help students by generating new ideas, guiding discussions, and providing personalized feedback. Dynamic engagement. AI assists in monitoring group dynamics, helping educators to intervene and support students effectively during collaborative tasks. Enhancing engagement and communication. Enhancing engagement. AI technologies facilitate personalized learning experiences, which can increase student engagement and participation during collaborative activities. Virtual collaboration tools. AI can power platforms that facilitate communication and collaboration among students, such as virtual classrooms, discussion forums, and project management. Interactive simulations through gamification. AI can incorporate gamification in collaborative activities, such as leaderboards, badges, and rewards, to motivate students and make learning more engaging. Approaches for successful AI collaboration in classrooms. Real-time assistance. AI provides real-time guidance during group discussions, enhancing collaboration. Smart task assignment. AI helps in efficiently assigning tasks and managing group dynamics. In this slide, we focus on how AI can enhance both student cooperation and teacher-student communication. AI tools play a significant role in facilitating real-time communication and project management, enabling students to collaborate effectively regardless of their location, thus enhancing teamwork. AI tools for collaboration. AI tools can facilitate seamless communication and project management, ensuring that students can work together efficiently, even when they are not in the same physical space. Improving feedback mechanisms. AI systems can analyze student interactions and provide tailored feedback. This fosters better understanding and communication between students and teachers, enhancing the overall learning experience. Equitable participation. AI-driven platforms ensure that all students contribute to group projects. By addressing disparities in participation, these platforms promote a more inclusive learning environment, ensuring that every student has the opportunity to participate and benefit from collaborative learning activities. Assigning AI. 7 ways of using AI in Class AI Tutor. Increases knowledge by providing additional learning resources. AI Coach. Enhances metacognition by helping students reflect on their learning process. AI Mentor. Provides balanced, ongoing feedback. AI Teammate. Boosts collaborative intelligence in group projects. AI Tool. Extends student performance by offering supplemental tools and resources. AI Simulator. Aids in practice through simulations. AI Student. checks for understanding, and provides insights into student learning. Here are some more details of the 7 ways of using AI in class. Dr. Aaron Walker's Research and Flipped Classroom Model. Dr. Aaron Walker focuses on integrating AI with culturally responsive pedagogies to enhance collaborative learning, aiming for equitable educational technologies. Her research emphasizes engaging students with lecture content at home and participating in discussions and practical activities during class, fostering active learning. This approach significantly boosts student engagement and learning effectiveness. References and further reading. For those interested in further exploring the integration of AI in collaborative learning, the following references and readings are recommended. Thank you for your time. We hope this video has enlightened you on the use of generative AI for faculty and students. We hope you have a great time learning at Aventis Graduate School.